installing a data analysis software on a personal computer, a common question that beginners ask as they navigate their interest in data science using code or command line scripting is this: how do I begin, or how do I start data analysis by writing codes? In this lesson, we provide a soft landing and demystify data analysis using codes and command line scripting in RStudio for complete beginners. The current lesson is for absolute beginners, individuals with no prior experience with RStudio. So at the end of this lesson, you should be able to list the four quadrants of your RStudio interface, use RStudio as a fancy calculator, define objects as using RStudio programming, create new objects, store and assign values. Now, to follow along and walk through the practice exercises, you need to have RStudio already installed on your personal computer, whether that's a Windows, a Mac, or a Linux. If you would like to learn how to install RStudio, please see one of our previous videos. RStudio Integrated Development Environment, or IDE, allows us to interact with R more readily. When you open RStudio on your personal computer, you should see four windows. These are the code editor window, the console window, the environment window, the plots, files, packages window. The code editor or source window is located in the upper left pane and supports direct code execution. In this window, you will be able to create R notebooks, R markdowns, display your code, create HTML documents, and do so much more. Now, any objects that we create in R must live somewhere. And as you will soon see in RStudio, all the objects that we create live in the global environment and are displayed in the environment window, which is located in the upper right pane. In this window, you can see all available data, functions, and variables in your dataset. When you press the History tab at the top of the environment window, you will be able to see previous code that you have run in the console. The Help, Files, and Plot window located in the lower right pane allows for easy access to your files. You can preview plots and documents that you are creating, and you can also access help right next to the code that you are writing. The RStudio console located in the lower left pane is where you can type in individual lines of code or command. It is also where the output will appear when you run your R script. Now, let's use RStudio as a fancy calculator. We will enter all of our commands in this practice exercise in the console window, that is this window that's located in the lower left pane. Let's do that. With RStudio open, let's use RStudio as a fancy calculator. So everything we're typing right now is going to be in the console window, which you can find in the lower left corner. And so I'm just going to type the first thing, 2 plus 2, 2 plus 2, and then press enter. You can see the result is printed as 4. Next, I'm going to type 2 times 2 plus 3. 2 times 2 plus 3 is 7. Now let me ask 2 raised to the power of 3 plus 3. The result is 11. Let's type pi. If you guys know from basic math, pi is 3.142. That's that. Now let's check the exponent of pi minus pi. That's 19.99. Let's look at log of 20 plus pi. That's 3.14.1632. And then let's look at 0.5 divided by 1 million. You can write 1 million as 1e6, and the result is in the negatives. So this is how you could basically use RStudio as a fancy calculator. And now we've typed all of these things in the console. Although literally you could type every code that we have written in the script window, which is what you can see up here as well. If I did all of this in the script window, all I needed to do is I have typed it here, I select that. I could just literally select everything and then hit the run button, and you see all of my results will display in the console window. Once you start writing codes, especially in the R script window, you want to develop the practice of commenting your codes or annotating your codes. Begin each line of comment with a pound sign, which is the comment symbol, and then you add a single space. Your comments, for the most part, should explain the why, not the what. Then you also want to use commented lines of either hyphens, dashes, or equal signs to break up your file into easily readable chunks. You'll see this in practice in some of our R codes very soon. An R object is simply a collection of data or variables as used in other programming languages. In a subsequent video, we'll learn more about object classes in R. Creating an object in R is very easy. You create an object by simply typing the object name and assigning a value to it. Although you can use the equal sign as the object assignment operator, for all of our tasks, we will be using the more conventional left pointing arrow as our object assignment operator when we create objects. Now you create objects like this: X, the object assignment operator, and you're assigning a value of 10. And you interpret it as object X gets value Y. Now you can think of an object in R as a shoebox with a name. As seen in this slide, the name of the shoebox is X. And you can imagine that it's holding a scrap of paper with the number 10 on it. Now let's create a few objects in RStudio. This time everything we're typing is going to be in the script editor window as opposed to the console window. So we have all of our values in the script editor window. The first here is the task is I'm creating an object that I will call object underscore one. That's the name, and I assign it a value of 3, and I click on run, and see the object is printed. If you look in the environment window, you can see a new object appears in the environments window. Before now it was empty. The second task is I'm creating an object I call object underscore 2, assign it a value of 2.5. That's already typed before, and then run that. If you look in console, you see the object my command shows there, and then the object that's created is in the environment. You see those two objects. Now let me print the object to screen, object 1. Just select that and then click run. So you see object 1 has a value of 3. Let's also confirm what object 2 is. Run that. As expected, object 2 has a value of 2.5. Finally, let's add object 1 plus object 2, and then the answer object 1 plus object 2 is 5.5, which is what you will expect. Going back to our illustration of objects in R as a shoebox, it is worth mentioning that you can name your object, that is the shoebox, anything you want with a few exceptions. You can store any value in it with a few exceptions too. For example, we could literally name an object Scooby-Doo, but that will not be very informative. So with that in mind, there are a few rules you want to observe when naming your objects in R. One, object names should be short and meaningful. Your object names should be lowercase. The object names cannot start with a number. You get an error once you try to start an object name with a number. You want to use an underscore or what we call snake case to separate words within an object name. And as much as possible, you want to avoid using names of existing functions like mean, median, or other existing variables. Doing so will cause confusion for those who are going to read your code. You use quotes to tell R to interpret something as a string. You can use single or double quotes to delimit character or string constants in R. Single or double quotes can be used interchangeably, although double quotes are preferred. You should note that even when single quotes are used to delimit character constants, they are printed using double quotes. Let's see this again, how it works by creating a few string objects in R. So the first object here is we're creating a string object that we will name string underscore O, and we assign it a value, a string or character of hello, and then we'll run that. We see the object in the environment appears, and then the second object, let's print out string O. As expected, you see it in double quotes as hello. You see the output in the console window. Now the second string object we're going to create, we call it s underscore object, and we assign it the string character single quote. In this case, we're using single quote strings to create this object. Run that. As expected, you see your code runs in console. The new object, you can see it in the environment. Now let's print s object, that's single quote. Now one of the things you notice here is that although you created the object with a single quote, but when it gets printed as double quotes. So that's something you want to keep in mind. R is case sensitive. In most cases, spaces don't matter, but uppercase letters are not the same as lowercase letters. To demonstrate this, let's create some more objects and make a few assignments in R. In this case, we're creating a new object that we call R underscore is cool, and we assign it the value of 2 raised to power 3. Okay, let's do that. Now let's print out the object. You type the object name R underscore is cool. You print that out, R underscore is cool is 8. But notice what happens when we replace the lowercase r with uppercase R and try to print this object. So we type that and then print it out. As observed, R throws an error message because it does not recognize the object name. The implication of this is that you must be completely precise in what you tell R to do. Typos matter, case matters. The C function, or what we call concatenate or combine, is used to combine or concatenate its arguments in R. You can use the C function to combine numeric values into vectors. You can also use the C function to combine characters or strings. As before, let's create a few objects in R using the C function. First, we're going to assume that we're creating an object that we'll call name gender, and this object gender is going to contain 3 strings, male, female, male. We're going to use the C function to do this. Next, we'll combine the numbers 1 through 5 and name that new object my data. And as we'll see, both gender and my data are called vectors. That is single entities consisting of a collection of things. Let's create these 2 objects in RStudio. Use the C function to concatenate or combine values. So here we're creating an object called gender, which is made up of 3 strings, male, female, female, and then we're going to combine all of those with the C function. So that's type, let's run that. It's created. Now let's print gender and see the results in console. As you can see in the console, you see the male, female, male printed. Next, we'll create an object called my data, which takes in the numbers 1 to 5. Again, we're using the concatenate or combine function here. Print that. my data, you can see the values 1, 2, 3, 4, and 5. You would have noticed that for all of the objects we have been creating, first you create the object, and to see the values or contents of the object, you type the object name, which causes it to print to screen. You can shorten this task. That is, if you want to create an object and cause it to print to screen at the same time, you can surround the object, the assignment, with parentheses. So this will cause print to screen to happen. Let's see this happen. So previously, we will create our vectors like numbers combine 1 to 8, and then to print it, we'll have to actually type in the object name, in this case numbers. But we could literally have done that if we wanted to create and print the object to screen at the same time. As we mentioned in the lecture, we surround the assignment, the object we just created, with parentheses. So in this case, we create the object and then parentheses at the beginning and parentheses at the end. So when you run this, it creates the object and it prints it to screen at the same time. Let's see this. So you see that this is a numbers that we created by using the concatenate function to join values 1 to 10, and we can see it printed in the console. Finally, let's create a sequence of numbers using the seq function, seq parentheses. We're going to create a sequence of numbers that's from 0 to 5 with a length of 10, and we're going to assign it to an object that is named seq underscore whence. As usual, that is the function. We're using the seq function to create that. Now run that, print it out to screen, and we'll see the values. And as we mentioned before, you could create it and print to screen at the same time by surrounding the assignment with parentheses on both sides. So what we did here is basically the same thing as the first one, except that this second one, we are, instead of a length of 10, we're creating a sequence of numbers from 0 to 5 with a length of 5. So if you remember when we were talking about the environment window, we mentioned that if you click on the history tab, you will be able to see all the previous codes you have run. So let's click on the history tab, and if you click on, as you see here, if you scroll, you see literally every code that we have run, including the comments. For this exercise, we can view all of this in the history window. So this is something you might find useful if you need to look at the history of the codes or the commands, as well as the comments and annotations that you have made. In this lesson, we learned that the RStudio interface has 4 panels. The lower left pane, which is called the console window, and that's where you can type in individual lines of command, and also where the output will appear when you run your R script. The upper left pane is the code or script editor window, and that is where you can create R notebooks and type in your scripts, and also supports direct code execution. Then in the environment window, located in the upper right, is where you see all the objects and variables that you have created. The front pane located in the lower left is the Files, Help, and Plot window. And that is where you preview plots and documents that you are creating. We also learned that you create objects in R by writing the name of the object and then using the assignment operator to assign a value to that object. And although you can name an object anything you want with a few exceptions, you want to use names that are meaningful and informative. Your object names cannot start with numbers and should not start with names of existing functions. We learned that R is case sensitive, and that while spaces don't matter in most cases. You want to keep in mind that uppercase letters are not the same as lowercase letters. And then we learned that it's good practice when typing scripts in the script window to comment your code, and you insert a comment by first typing the pound sign, and anything after the pound sign is not executed as a code but rather viewed as a comment.